Hey folks, welcome back. In this video, I'm going to go over 5 worked examples on how to use significant figures. If you haven't already done so, check out my other video covering the theory on this topic, where I talk about the 4 main rules for deciding whether a number is a significant figure. Let's get started. Now, question 1 says a physics pupil tackles the following question. How much work must be done to increase the potential of a charge of 6.4 times 10 to the minus 7 coulombs by 560 volts? Using the formula W equals QV, this is a formula you will come across later in the higher course, but for now I'm giving you it because you've not come across it yet. Using this formula, they obtain an answer on their calculator of 3.584 times 10 to the minus 4 joules. So all you do is you multiply the charge by the voltage, those two numbers together, and you get out this number on the calculator. Part A is asking what is the least accurate value in the question, i.e. the least number of significant figures. Well, if we look here, we'll see there's 6.4, that is 2 significant figures, because remember, any digit in scientific notation is going to be a significant figure, and over here, remember, the 5 and the 6 count as significant figures, but the 0 doesn't. So in the question, both of our numbers are to 2 significant figures, so the least number of significant figures must be 2 significant figures. Part B says write the final answer using an appropriate number of significant figures. So if we write it to this appropriate number, which is 2 significant figures, then we end up with an answer of 3.6 times 10 to the minus 4 joules. In question 2 it says in each of the following cases, the stated value has too many significant figures. The appropriate number of significant figures is stated in brackets after the quantity. Round each quantity to the correct number of significant figures. So in part A we've got 11.85467 volts. And it says to round this to 3 significant figures. Now to do this, we're just going to take it to 1 decimal place, so that's going to become 11.9 volts. In part B it says 50.7835 Hz to 2 significant figures. Well, this is going to round up to 51 and that will give us our 2 significant figures, so 51 Hz. For part C we've got this pretty small number here and we're asked to state it to 3 significant figures, so the easiest way to do this is to use scientific notation. So we put the decimal point after the 7 there and we're going to end up with 7.12 times 10 to the power of minus 7 meters, because remember every digit in scientific notation is a significant figure. And lastly, part D, 2.998 times 10 to the power of 8 meters per second to 2 significant figures. If we want to keep this in scientific notation, we're going to make it 3.0 times 10 to the power of 8 meters per second. Question 3 is like your standard 3-mark calculation question, but we're also going to take into account significant figures. So a resistor has a current of 2.5 amps through it when the voltage across it is 8.95 volts. Calculate the resistance of the resistor, writing your final answer with an appropriate number of significant figures. Now, the first thing we need to realise is that the least number of significant figures in the question is 2, because we've got 2.5 amps for the current and the voltage is actually to 3 significant figures. So the least number of significant figures is the 2 from the current, so we need to state our final answer to that 2 significant figures. So writing down what we know from the question on the left hand side, we're trying to find the resistance. Our voltage is 8.95 volts and our current is 2.5 amps. We then want to write down our equation, and this one is going to be Ohm's law, V equals IR, and then rearranging for the resistance R, we get R equals V over I. Substituting in our voltage and our current values, we get 8.95 over 2.5. So you put that into your calculator and you should get 3.6 ohms if you state it to 2 significant figures. Question 4 has 3 parts to it, A, B and C, and all of them are calculation type questions, so we're going to go through each one taking into account significant figures. So in question 4 it says find the answers to the following questions, stating your final answers to an appropriate number of significant figures. In part A, calculate the time taken for a signal to travel along a glass optical fibre of length 40 kilometers. The speed of light in the optical fibre is 2.0 times 10 to the 8 meters per second. So this is going to be a classic speed distance time calculation. So writing down what we know on the left hand side, we're trying to find the time. We know that speed is 2.0 times 10 to the 8 meters per second, and our distance is given as 40 kilometers, but remember we need to convert from kilometers into meters, so this becomes 40 times 10 to the power of 3 meters. Choosing our equation, we've got D equals Vt, and then rearranging for our time, we get time equals distance over speed, and substituting in our numbers gives us 40 times 10 to the power of 3 divided by 2.0 times 10 to the 8. And now just before we state our final answer, we want to state it with an appropriate number of significant figures, which is going to be the least accurate value in the question. So if we look at the question, we've got 40 kilometers, that's 1 significant figure, and 2.0 times 10 to the 8, that is 2 significant figures. So the least accurate value must be 1 significant figure from the distance, so we need to state our time answer to 1 significant figure. So this becomes 2 times 10 to the minus 4 seconds. Part B, a 300 watt games console operates at 9.0% of its power rating when on standby. Calculate the number of kilowatt hours used by the games console whilst on standby for 14 days. So this is a sort of problem solving question involving percentages, and what we're going to need to do is work out how many kilowatts we have from the 9% of 300 watts, and then we're going to need to work out how many hours are in 14 days, and then we multiply our two numbers together and we get how many kilowatt hours there are. So the first step is to find 9% of 300, which equals 0.09 times 300, which is 27 watts. But because we're using kilowatt hours in this question, we want to convert watts into kilowatts, so we divide this by 1000 and we get 0.027 kilowatts. The next step is to find how many hours are in 14 days. So 14 days is 14 times 24, which gives us 336 hours. The last step is just to multiply our two numbers together and we get 0.027 times 336, which gives us 9 kilowatt hours. And notice we've stated this to one significant figure because the least accurate value in the question was one significant figure from the power rating, that 3 value there. Lastly, part C, a parachutist lands badly and is airlifted to hospital by helicopter. A winch is used to lift the stretcher and parachutist into the helicopter. If the combined mass of the stretcher and parachutist is 90.0 kilograms, calculate the total weight. So this is going to be a W equals mg calculation. So writing down what we know on the left hand side, we've got W equals question mark, M equals 90.0 kilograms, and G equals 9.8 newtons per kilogram since it's on Earth. Writing down our equation, W equals mg, we then substitute in our numbers, so we get 90.0 times 9.8, which gives us a final answer of 880 newtons stated to two significant figures. Now the reason we've used two significant figures is because of the G value which was chosen as our gravitational field strength to be 9.8, so in this case that would be our least accurate value, because the mass here is given to three significant figures, whereas this is two significant figures. That's all from me guys, I hope you found the video useful. If you did, give it one of these and subscribe, and I'll see you in the next one. Take care.